Okay, so in this second video, we're going to take a look at piecewise functions and how to solve them. And we're also going to look at how to graph them. But in this very first problem, this is cell number 1. That's what this means right here. So this is just the first problem. Its answer is not 20, so I'll show you how this little puzzle works. So this is find f of 6. So 6 is your x, just like f of x is what we're looking for. You're looking for the y value, like the f of x value. So what you do is you look at the domain here. You use x plus 5. You can think of the comma as just the word when. So when x is less than or equal to 0, you use the top function. If x is bigger than 0, you use the bottom function. Since we have 6, 6 is bigger than 0, you're going to put the 6 into this function here, the one on the bottom. So you do 3 times 6, which is 18. 18 minus 1, which is 17. That's the answer to the first problem. And you've got the answer of 17 right here. So this is problem number 2 now. So it started with problem number 1. This is problem number 2. So this one says go find f of negative 5. This is the x, negative 5. So you're going to use this top function here because your x is less than 1. It's a negative 5. So you're going to put the negative 5 into the top function right here where this x is. So negative 2 times negative 5 equals positive 10. And you're going to look for that negative 10, which is on the next page. Okay, so since this is your third answer, we're going to put a 3 right here. And so this problem is asking to find out what g of negative 2 plus g of 2 is. So again, the negative 2 is your x. That is less than 0. So you're going to put negative 2 into this top function right here. So negative 2 squared is a 4 plus a negative 3, negative 2. Well, it's plus because we're going to have a negative times a negative, which makes a positive 6. So that first piece of this is a 10. And then you're going to take a look at the g of 2 part of this. 2 fits the domain here. X is greater than or equal to 0. So 12 is always your answer. So that's 10 from this side. We got 12 from this side. So we've got 22 is our final answer to this problem. So you look for 22 somewhere where it says answer, and you're going to put that as a number 4. That'd be your fourth problem. But I can do a couple more examples here just to make sure that you understand like what this over here means to do. If v of 10 equals 57, again 10 is your x, 57 would be your y. So since 10 is going to fit the domain here, it's bigger than 5, you're going to put a times t, which is now a 10, so there'd just be a times 10 minus 3 has to equal a y value of 57. So then you just use some algebra skills here to solve this out. You could call this a 10a instead. Add the 3 over here to create a 60. Divide by 10 both sides, and you've got 6. Alright, now let's look at a couple more examples, this time where we're going to graph a function. So for this sample 1, we've got a function defined as x plus 3 when x is less than 0, and we've got f of x equals negative x plus 2 when x is greater than or equal to 0. So again, 0 is your domain. Sometimes students like to draw out a little number line, put the 0 here. Like on the left side of 0, you're going to use the x plus 3 function. On the right hand side of 0, when x is bigger than 0, you're going to use the negative x plus 2 function. Just to visualize it on a number line, sometimes that helps. So if we take a look at just this first part, we'll do this one in blue, x plus 3. So you've already got it set up in like y equals mx plus b form. The 3 is your b, your y-intercept. 1 would be your slope. So you just go up to 1, 2, 3 right here. This would be your y-intercept. Your slope is 1. So essentially you've got this line. We're going to erase this part, but we'll just draw it for now. So that's what this line is right here. But we only use this blue line when you're less than 0. So that's why we're going to erase anything to the right hand side of 0. So let's change color and do negative x plus 2 in a different color. So we've got 2 as your y-intercept right here, and it's a negative slope, -1 slope, so it's going to go down 1 over 1. It's going to go to here, to here, to here, like this. Okay, so the last thing I want you to look at is this first equation here in the blue should actually have an open circle at 0 because it wasn't equal to right here. This pink one, since it's equal to 0, we're going to have a solid dot right here. So that's what this function would look like. Now you can see this is not connected. So it's asking you right here, is this a connected function? It isn't, because there's this little gap right here. A function would be connected if you could just draw the whole entire function without ever lifting your pencil up. Okay, let's take a look at the second problem. We've got g as x plus 3 and g equals 1. But this domain is different than this one right here. This x is not equal to 2 means you're going to graph x plus 3 everywhere except at 2. So when x is 2, 1, this 1 came from this 1 right here. So otherwise, we know how to graph x plus 3. So let's graph that. We've got a y-intercept of 3, slope of 1. So it should look like this. This is our problem. So the only problem, though, is this is not, like, the top function right here is not defined at 2. So at 2, there should be a little bitty gap right here. So we should have, technically, a little open circle going on right here, because the top as x plus 3 is not defined at x equals 2. It exists everywhere else. However, when x is 2, the y-coordinate is 1. So when x is 2, your y-coordinate is 1. So this part right here is just a little dot. So this graph here has an open circle at 2, comma, well, it looks like it's going to be a 5. It's trying to be a 5. But then at 2, 1, we've got a dot going on for this part here. And again, is this connected? No, this is not connected because we can't draw this entire function without lifting up our pencil. Alright, so let's look at example number 9 here. We've got g of x defined as x when x is less than 1. And it's also a parabola when x is bigger than 1 or equal to 1. So what could also help is if you make a t-chart. So I just picked a few values here. So 1 being specifically, I put 1 here in the middle because 1 is where these two functions either separate or are connected together. So if you take a look at -1 for x, this has to go into the top function here. So x is -1, so the y-coordinate is also -1. You could plot that, -1, -1 right here. Then you have 0. So if x is 0, it still goes into the top. And your y value is 0. If x is 1, so technically we need to go to the bottom function now. So if x is 1, 1 squared is 1. But again, you could just draw x because that has a slope of 1 and a y-intercept of 0. So hopefully you know already that this is what x looks like. Now, there should be an open circle right here, but watch what's going to happen. Well, actually it goes a little bit further up to here because that 1 is where this one kicks in. So if it's 1, we have 1. If we have 2 for x, 2 squared is 4. Goes right here. So 2 comma 4. And 3 squared would be 9, which would be off the charts. But what's going to happen is this parabola is going to connect to this x function. And just by plotting a few points, you can see that that is going to happen. So really, there should be an open circle here at 1 from the top, but because the bottom has a closed circle on top of it at 1, 1, this is a complete and connected function. Alright, so we're going to take a look at one last example with the piecewise functions, and that could be 13a. So what you got to do is, first of all, you notice that these two functions split apart at x equals 1. So we're going to have a function go here, comma, x is less than, solid dot here, so less than or equal to 1. And then we're going to have another function here for this piece. That'll be a comma, x is greater than 1. So now all you have to do is to figure out their mx plus b. So this has a b, or y-intercept, of 2. The slope is going down 2 over 1. So this is a negative 2x plus 2. That's what this graph is. So this graph, since it's not crossing the y-axis, you have to imagine it going and hitting it. So we have to extend it out until we get down to a negative 3. And this has a slope of 1 over 1, so the slope is 1. So it's a 1x, or just x, and then a minus 3. But being sure to have the domain out here.